Welcome to Brain Vision.
So here, if there's no deflection, this means that the velocity is simply going to be equal to the magnitude of the electric field divided by the magnitude of the magnetic field. Here, we only have a magnetic force, and there is a centripetal acceleration. So we can say that the magnetic force equals the mass times the centripetal acceleration. And so we can say that the absolute value of the charge times the velocity times the magnitude of the magnetic field will equal the mass times the velocity squared divided by the radius. For part A, they simply want the velocity, so this is going to be equal to the magnitude of the electric field divided by the magnitude of the magnetic field. This is going to be equal to 1.56 times 10 to the fourth. This will be volts per meter, and then this will be divided by 4.62 times 10 to the negative third Teslas. And this is giving us 3.38 times 10 to the sixth meters per second. So at this point, part B, we can draw a diagram of what's going on. So in this negative y direction, we have the electric field. In the negative x direction, we have the velocity. And then going into the page is going to be the magnetic field. So for parts, rather this would be for part B, this would give you a direction of all the vectors. For part C, however, we want to find the radius. So we are simply taking this equation right here and isolating r. So r is going to be equal to mv divided by the absolute value of the charge times the magnitude of the magnetic field. This is going to be equal to the mass of an electron, 9.11 times 10 to the negative 31st kilograms, and then times the velocity that we just found, 3.38 times 10 to the sixth meters per second, and then divided by the charge on an electron, so 1.6 times 10 to the negative 19th, and then times the magnitude of the magnetic field, 4.62 times 10 to the negative third Teslas. And we find that the radius is going to be equal to 4.17 times 10 to the negative third meters. So this would be your answer. Now, however, the other question to part C is asking for the period. So we can say that the period is simply going to be equal to the circumference divided by the velocity. So we can say 2 pi r divided by v. So we can say 2 pi times the r that we just found, so 4.17 times 10 to the negative third meters, and then divided by the velocity of 3.38 times 10 to the sixth meters per second. And so the period is going to be equal to 7.74 times 10 to the negative ninth seconds. So this would be the time per revolution. That is the end of the solution. Thank you for watching.